Hi there. Today we're going to learn about outdoor air pollution, specifically how we get smog, the difference between good and bad ozone, something called a thermal inversion, and some modern inventions which are pollution solutions. There are many sources of outdoor air pollution. Some of them are natural, like a volcanic eruption. Most of them are anthropogenic, primarily from mobile sources like different forms of transportation, but also from stationary sources like power plants and industry. We define air pollution as anything in the atmosphere that's harmful to plants, animals, humans, or the environment. And we categorize two broad groups of pollutants. We have primary pollutants, which are released directly from the source into the air. And then we have secondary pollutants, which form from chemical reactions of one or more primary pollutants with something in the air, usually water vapor. And two examples of secondary pollutants are ground level ozone and acid rain. In 1970, the Clean Air Act identified 6 criteria air pollutants as being the most harmful pollutants to humans. And you can remember what these are with this mnemonic SPLONK. S stands for sulfur dioxide, P is particulate matter, L is lead, O is ozone, N is nitrogen dioxide, and C is carbon monoxide. Most of these air pollutants come from the combustion of fossil fuels. And if you remember what fossil fuels are, this will make sense to you. Fossil fuels were once alive. They are the remains of ancient plant and animal material, and therefore they are made of the CHNOPS elements. So when we burn them, we get pollutants that contain the CHNOPS elements, such as sulfur dioxide, nitrogen oxides, carbon oxides, particulate matter, and something called VOCs, volatile organic compounds, of which hydrocarbons, which is what gasoline is, are an example. Before we can learn how smog is formed, we have to understand what ozone is and the difference between good and bad ozone. Ozone is O3. It is 3 oxygen atoms chemically bonded together. When we find ozone in the stratosphere, it is good and necessary for life on our planet because it blocks harmful ultraviolet radiation, which is a mutagen. When we find ozone in the troposphere, it is bad ozone because it is a pollutant that can lead to smog formation. The Bozeman guy is going to show you how ozone is formed in the stratosphere.
This near the bottom is called tropospheric ozone. This is that bad ozone. It can create smog, also leads to lung irritation, can lead to things like lung cancer. As we move farther and farther up, we get into the stratospheric ozone. That's the ozone we're talking about. This is the ozone layer, large amounts of ozone high in the atmosphere. It's this O3 molecule. It doesn't start as an O3 molecule. We basically have a bunch of regular oxygen, diatomic oxygen. It's hit by ultraviolet radiation and it breaks it apart into 2 atoms of oxygen. This free atom of oxygen bonds to diatomic oxygen, and now we've got our ozone. That's how it's formed. We need the radiation to form the ozone. It's also how it breaks down. So if it's hit by another bit of UV radiation, then it breaks that again, and now we're doing this cycle. We're doing the cycle of solar formation when we take regular oxygen, hit it with a photon, break it into these free atoms, which then bond to another oxygen atom to make ozone, and then we have solar breakdown. That's when we have the ozone, it's hit with a photon, we break it down, and then we make that good old-fashioned oxygen again. And so it's a nice cycle. As long as the sun is shining, we're going to have ozone. And the importance of ozone is protection. So if we look at the amount of UV radiation, it moves right through those layers in our atmosphere. UVB is mostly filtered out, and UVC is completely filtered out. And you might think, why is
So at the ground level, there is a natural cycle of ozone formation, and it's very similar to what you just saw in the video with one additional key player, and that is nitrogen dioxide, which comes from cars. It's what comes out of the tailpipes of cars as a result of combustion of fossil fuels. So keep in mind that ozone formation, generally speaking, when we find it in the stratosphere, is good and necessary. But the problem is when we get too much ozone at ground level, because it's an ingredient for smog. So first, let's understand the natural cycle that's happening in the troposphere at ground level. You have nitrogen dioxide, which is coming from cars, and the sun will naturally break that apart. Sunlight will break chemical bonds often, and it will break it into nitrogen monoxide and free oxygen atoms. These free oxygen atoms can now combine with O2 gas in the atmosphere, in the air, and create ozone. That's the natural formation of ozone at ground level. Then this is what's key to this chemical reaction is it happens in the daytime when the sun is out. The sun is necessary for this reaction to take place. But at night when the sun goes away, part of the natural cycle is natural ozone destruction, so we don't get too much ground level ozone built up. So how does that work? The ozone combines with nitrogen monoxide and it forms O2 gas and nitrogen dioxide, just like what we started with. That's all good. That's a natural cycle. But the problem comes in when that natural cycle is interrupted, and that's when we can get smog. This is the beautiful Golden Gate Bridge, and in the background you see this brown layer of smog, which is a result of nitrogen dioxide and the chemical reaction that forms smog. So how does that happen? Well, we're talking about two primary pollutants now, nitrogen dioxide and volatile organic compounds. These are, you can think of volatile organic compounds as smelly things like nail polish remover and gasoline. They are things that vaporize at room temperature. Vaporize means they are in a gas form. They emit a gas. Nitrogen oxides come about because our atmosphere is mostly nitrogen. It's 78% nitrogen gas, and when we combust fossil fuels, it creates nitrogen oxides. We can also get nitrogen oxides from forest fires. So here's an overview of how smog, which is a terrible form of pollution with many negative health impacts, how smog is formed. You're going to get a lot of smog in urban areas where there are a lot of cars. So think San Francisco, Los Angeles, Mexico City, for example. And these two primary pollutants, nitrogen oxides, which come from cars, and volatile organic compounds, which also come from cars, but they can come from natural sources like certain trees as well. When the conditions are such that there's a lot of sunlight and there's warm temperatures, like you get in LA and Mexico City a lot, they will undergo a chemical reaction and form ground level ozone and another ingredient of smog called PANS, which is an abbreviation, but you just need to know it as PANS. So here's a picture illustrating what I just said on the previous slide. You have lots of sources of these primary pollutants of nitrogen oxides and VOCs. Here's all the different places they can come from, and they are going to react when there's a lot of sunshine and warm temperatures to form ground level ozone and PANS, which are the ingredients of photochemical smog. So let's break it down even further. This is a picture of how photochemical smog is formed. So what happens is you get nitrogen dioxide, which is coming from cars. The sunlight breaks it down into nitrogen monoxide and oxygen atoms. But instead of it being able to form ozone, like I showed you in a couple slides prior, if there are too many VOCs present, then the nitrogen monoxide is going to bond with these VOCs, and it's going to form photochemical oxidants like PANs, which is going to lead to the production of smog. So in other words, the VOCs are going to take up the free nitrogen monoxide, and they're going to prevent it from making and breaking down ozone. So down here, this is a copy of part of the diagram I showed you a couple of slides ago. Instead of allowing natural ozone destruction, the nitrogen monoxide is not around anymore. It's being bonded to the VOCs, and so you're not going to get the natural breakdown of ground level ozone. Instead, it's going to combine with these pollutants called PANs, and it's going to create smog. It is important to note that smog is made even worse when temperatures are high, because when temperatures are high, you get more VOCs. Now, why is that? Because a couple reasons. When temperatures are high, you get more transpiration from the leaves of plants. And remember that one natural source of VOCs is from the leaves of certain plants. Also, when temperatures are high, you get increased evaporation of volatile liquids like gasoline, which are, spilled onto the asphalt, and they're going to create more VOCs. And high temperatures also mean things like more businesses and homes are turning on air conditioners, which are leading to increased use of electricity, which is being burned at coal-fired power plants, which is creating more nitrogen oxides. So in short, high temperatures and sunlight leads to faster ground level ozone formation. Please take a 5-minute break, and we will wrap things up after the break.